All right, guys, today we're going to review mean absolute deviation. We talked about how to calculate mean absolute deviation and what it is. So let's review. So what is mean absolute deviation? The mean absolute deviation of a data set is the measure of the average distance between each value and the mean. Okay, so on average, how far away is each data point from that central number, from that mean? Okay. So why do we calculate this? What does absolute value tell us about the data set? Okay, the mean absolute deviation tells us about the variation of a particular data set. So we talked earlier in the unit about how the word variation tells us there's a variety of data. So when we're calculating the mean absolute deviation, we're calculating how much variety or how much variability, how much variation that a data set has. Okay, so if there is a high MAD or a high mean absolute deviation, that means that our data points are far away from one another. It means that they're very different, and it means we have lots of variation. So if that number is really, really high, it tells us that our data points are spread far apart. Okay, if we have a low mean absolute deviation, our data points are going to be close to one another. They're very similar, and there's not a lot of variation. So if we have a low mean absolute deviation, that means the data set looks pretty similar. Okay, everything is really close to another. There's nothing that's really spread out very far. It represents not a lot of variation. Okay, so how do we calculate mean absolute deviation? First thing that we're going to do, if it's the mean absolute deviation, the very first thing we need to do is to calculate the mean. Okay, so we're going to find the mean. Then what we're going to do is we're going to find the difference between each data value and the mean. Okay, so we're going to figure out their distance, how far away they are from each other. If we want the average distance, then we need to find the difference between those 2 points. Okay, so we find the mean, we find the difference, then we're going to find the average or the mean of those differences. Okay. So we've got an example here. It says the following heights were collected from 5 students, 6th graders in Miss Arnold's math class. 55 inches, 47 inches, 54 inches, 60 inches, and 54 inches. It says find the mean absolute deviation of the heights. So just like we used in class, you're going to use a mean absolute deviation chart to help you organize your work. And so the very first thing you need to do on your paper is to draw this chart. So we've got 4 columns in our chart, and you can just do like a double T chart. Okay, in the first column, that's where we're going to list our data. So on your paper, you need to draw a column and you need to title it, "This is my data." In the second column is where we're going to put the mean. So in your second column, you need to write the word mean or put an M, something to remind you that this is where the mean is going to go. In our third column is where we're going to set up our differences. Okay, so the differences is going to be the data minus the mean, because difference means to subtract. And then our last one is where we're going to be using our absolute value. Since we're talking about distance, we're going to be using absolute value because distance can't be negative. Okay, all right, so the first thing we're going to do after we draw our chart is to list our data. We have a 55, a 47, a 54, a 60, and a 54. Okay. Then what we're going to do is we're going to find the mean. Okay, and if you think back to earlier in this unit, the way to calculate a mean is to add all these data points together and then divide by how many there are. So we're going to add them 55 plus 47 plus 54 plus 60 plus 54, and we get 270. Then we're going to take our 270 and we're going to divide it by 5. When we do that, we get 54 is our mean or our average for the data set. Okay. Now, just like in class, I told you to draw an arrow down to the rest of this chart. Okay. The mean is the exact same for this entire data set. So I'm just going to write it in the first column and then I'm going to draw an arrow down because it's the same number for the entire data set. Then we're going to move over to our next column. And our next column is the difference. So that means we're going to subtract. And we're just going to work our way across our chart. Okay, so we have 55 minus 54 gives us a 1. 47 minus 54, I'm just going to plug that in my calculator because I'm not sure. When I do that, I get a negative 7. Then we have 54 minus 54 gives me a 0. 60 minus 54 gives me a 6. 54 minus 54 gives me a 0. Okay, so we're done with our third column. Then we're going to move over here to our fourth column. And if we're talking about distance, we always want the absolute value because distance can't be negative. So the absolute value of 1 is 1. The absolute value of -7 is 7. The absolute value of 0 is 0. The absolute value of 6 is 6. And the absolute value of 0 is 0. Okay, so we're almost done. We have our entire chart filled in. There's just a couple things left to do. Now we're looking for our sum, our count, and we're going to use those to help us get the MAD. Okay, so our last step here said to find the average of the differences. So we're going to be using our absolute value column, and we're going to find the sum, and we're going to divide by how many numbers there are in that column. So I'm going to take 1 plus 7 plus 0 plus 6 plus 0, and I get 14. Now my count, I'm just going to count how many numbers are. There's 1, 2, 3, 4, 5. So that's a 5. To get my MAD, I'm going to divide the sum and the count. So I'm going to take 14 divided by 5, and I get that the mean absolute deviation is 2.8. Okay. Now if we look at that number 2.8, we can see that it's a pretty small number, and we can assume that there's not a lot of variation in our data set, that the data points are pretty close together. And if we look at our data, that is absolutely true. There's not any numbers that are super far spread out. They're all pretty close together, and therefore they're close to the mean, which means they have a low mean absolute deviation.